everyone. Today we're going to talk about the magical world of atoms and molecules. Have you ever wondered why water stays in droplets? Or why it forms a spherical shape before flowing out of your cup? The reason for that is cohesion, which is, by the way, the main topic of this video. But first, we should learn some background information. Let's begin by learning about atoms. An atom is the smallest unit of matter that retains all the chemical properties of an element. Atoms are extremely small, typically around 1/10 of a nanometer, or 10 to the power of -10 meters across. The best image about how atoms look that I could find is the gold atoms under an electron microscope. In the picture, we see the atoms as the black spots. Now let's get even closer to the atom. What we couldn't see, but could model, is that the atoms are made from protons, neutrons, and electrons. Well, except for the normal hydrogen, it doesn't have a neutron. Protons carry a positive electrical charge, electrons carry a negative electrical charge, and neutrons carry no electrical charge. A fact for an atom is that if it has the same number of protons and electrons, it is electrically neutral. However, if an atom receives or loses an electron, it becomes either a positive or negative ion. Masses of protons and neutrons are much bigger than masses of electrons. So when calculating the mass of the whole atom, we can ignore the mass of electrons. The protons and neutrons cluster together in the central part of the atom, called the nucleus. And the electrons are somewhere outside the nucleus. Well, what keeps the particles together? Why do the atoms not fall apart? It's because of the special forces. There are 4 fundamental forces: gravity, electromagnetic, strong, and weak. Effects on gravitational and electromagnetic interactions can be observed in everyday life. Gravitational force is a very weak attractive force between all matter. It takes huge masses, like the size of a planet, for it to be felt. And the electromagnetic force deals with electrically charged objects. Objects with like charge repel each other. For example, 2 protons repel each other, while objects with unlike charge attract each other, like electrons and protons. The electrons of an atom are attracted to protons in an atomic nucleus by the electromagnetic force. Now, you're probably saying that electrostatic repulsion between positively charged protons should cause the nucleus to fall apart. But at the very small size scale of the nucleus, the strong force is much stronger than the electromagnetic force and holds protons and neutrons together. Now about a weak force. As you probably guessed, they are weaker than electromagnetic. Weak forces deal with particles smaller than protons. For example, quarks, that are building blocks of protons and neutrons. Now, I would like to draw an atom. I'm going to start with the nucleus. Assume I have 2 protons and 2 neutrons in the nucleus. Now we have a nucleus of helium, the second element in the periodic table. Actually, the picture that you are seeing right now is not fully correct. The strong interaction between protons and neutrons inside the nucleus is so strong that there is no empty space between protons and neutrons. So a nucleus is like a drop of an incompressible liquid. The next step is that since we have 2 protons, then we should have 2 electrons. So where should we put them? If a nucleus could be expanded to the size of a single blueberry, an atom would be the size of a football stadium. Most of the volume of an atom, greater than 99%, is in fact empty space. There is no way to draw a picture of an atom in scale. So let me put 2 electrons somewhere around the nucleus ignoring the right proportions. Electrons do not move around the nucleus randomly. There are some rules on how they behave. In 1913, Danish scientist Niels Bohr developed a model where electrons exist within principal shells or energy levels. An electron normally exists in the lowest energy level available, which is the one closest to the nucleus. In some circumstances, an electron could jump one level to another. That means it disappears from one shell and suddenly appears on the other. Each energy level could contain a certain number of electrons. For example, the first shell can have no more than 2 electrons, and the maximum number of electrons on the second shell is 8. Within each shell or energy level, electrons occupy electron orbitals. The area where an electron is most likely to be found is called its orbital. Orbitals have different names like S, P, D, F, G, and shapes. The first electron shell contains a single s orbital. The s orbital is the closest to the nucleus, and it fills with electrons first, before any other orbital. Hydrogen has just 1 electron, so it has a single spot on the s orbital occupied. For example, helium has 2 electrons, so it can completely fill the s orbital with its 2 electrons. The second shell contains 4 orbitals, 1 s orbital and 3 p orbitals. Starting from the third shell, shells contain s, p, and d orbitals. All those funny pictures of orbitals are derived from quantum mechanics equations, which can predict where an electron might be at any given time within a certain level of probability. Instead of drawing clouds, we could use orbital diagrams or box diagrams of electron configuration. Arrow represents an electron. Unpaired electrons could form chemical bonds. They are called valence electrons. For hydrogen, it is 1s1. That is, on the first level, in the s orbital we have 1 electron. And for helium, it is 1s2, which means that on the first level in the s orbital we have 2 electrons. The arrows here are to indicate that electrons have opposite spins. What is a spin? I do not explain now. I just want to mention that we could not find 2 electrons in an atom with the same characteristics. Electrons occupy different energy levels, different orbitals. And if 2 electrons happen to be on the same level, in the same orbital, they must differ by spins. Here's another example. Right now you're seeing the diagram of an oxygen. From this diagram, we see that the outer shell number 2 has 6 electrons in the 4 orbitals, 1 of which is s, and 3 are p orbitals. These orbitals are somehow mixing together. Hybrid orbital is an orbital created by mixing together atomic orbitals to form an equal number of new hybrid atomic orbitals. In case of oxygen, the 4 hybrid orbitals point toward the corners of a regular tetrahedron with a bond angle of 109.5 degrees. The familiar water molecule, H2O, consists of 2 hydrogen atoms and 1 oxygen atom. Oxygen atom does not have enough electrons to fill its outermost shell. Actually, it has 2 free spots. Similar to the oxygen, each hydrogen atom has 1 vacant spot. Hydrogen and oxygen atoms are joined together and share their unpaired electrons. When it happens, we said that the atom form chemical bonds with other atoms. In case of water, it means that 4 electrons are shared between hydrogen and oxygen. The repulsion from the lone pair combination is more than bond pair repulsion. As a result, the angle in a water molecule is 104.5 degrees, which is less than the true tetrahedral angle of 109. In water, shared electrons would be more likely found near the oxygen nucleus than the hydrogen nuclei. This gives the oxygen end of a water molecule a partial negative charge, while the hydrogen end has a partial positive charge. We say the water molecule is polarized. As a result of water polarity, each water molecule attracts other water molecules. Remember, opposite charges attract. The opposite electric charge between water molecules form hydrogen bonds. These hydrogen bonds cause the interesting properties of water, such as cohesion and adhesion. How about you go to your kitchen and get yourself a glass of water? Be sure to fill it to the very top, after which slowly add a few more drops. Notice that right before it overflows, the water forms a dome-like shape above the rim of the glass. It can stay above the glass because of the property of cohesion. In cohesion, water molecules are attracted to each other because of hydrogen bonding, keeping the molecules together at the liquid-gas or water-air interface, although there is no more room in the glass. Cohesion allows for the development of surface tension, or in other words, the capacity of a substance to withstand being ruptured when placed under tension or stress. This is also why water forms droplets when placed on a dry surface, rather than being flattened out by gravity. When a scrap of paper is placed onto the droplet of water, the paper floats on top of the water droplet, even if the paper is denser than the water. Cohesion and surface tension keep the hydrogen bonds of a water molecule intact and support the atom floating on the top. It is even possible to float a needle on top of a glass of water if it is placed gently without breaking the surface tension. The weight of a needle is pulling the surface downward at the same time as the surface tension is pulling it up, suspending it on the surface of the water and keeping it from sinking. Notice the indentation in the water around the needle. These cohesive forces are related to the water's property of adhesion, or the attraction between water molecules and other molecules. This attraction is sometimes stronger than water's cohesive forces, especially when the water is exposed to charged surfaces, such as those found on the inside of thin glass tubes, known as the capillary tubes. Adhesion is observed when water climbs up the tube. Notice that the water appears to be higher over here. This is because the water molecules are attracted to the glass walls of a capillary more than they are to each other, and therefore adhere to it. This type of adhesion is called capillary action. are cohesive and adhesive forces important for life? Cohesive and adhesive forces are important for the transport of water from the roots to the leaves in the plant. A similar action can be observed when I try soaking the paper in the water by placing only one small corner over here. Notice how the water crawled up the paper. The same thing happens in the leaves. This concludes my presentation. Thank you for listening.